how are you all? I'm back again with the mathematics shorts. So in today's video, we're going to be basically discussing about Cayley-Hamilton theorem. Now Cayley-Hamilton theorem, this is not included in JEE syllabus, but still we are talking about it because there may be questions in JEE exams where you actually have to relate the A inverse. For example, a square matrix of A is given and you actually have to relate this A inverse with some polynomial matrix involving some A equation of the matrix A. Some equation will be there and you actually have to find some scalar values. Now how to solve this question? You don't have to actually find out the values of the inverse and then actually solve. You have to take the help of Cayley-Hamilton theorem. Okay, so let us get started with the Cayley-Hamilton theorem. Now in linear algebra, Cayley-Hamilton theorem plays a very important role. Now it was actually named after the mathematician Arthur Cayley and William Rowan Hamilton, which actually states that every square matrix over commutative ring such as real or complex number or the integer satisfies this characteristic equation. अब characteristic equation का मतलब क्या है ना, जब भी आपके पास एक स्क्वायर मैट्रिक्स दिया जाया होगा, फॉर एग्जांपल A is a square matrix and we are actually have to find the characteristic equation. Now why do we need to find the characteristic equation? Because in Cayley-Hamilton theorem says that any square matrix satisfies its own characteristic equation. So how to calculate the characteristic equation? Now basically we won't go and dive into details of the eigenvalues and eigenvector calculation, but still we will talk about characteristic equation. ना इसको जो शॉर्ट ट्रिक है ना, इसको सॉल्व करने के लिए आप लोग जब भी कोई स्क्वायर मैट्रिक्स दिया होगा उसको क्या करना, तो ए को माइनस करना लैम्डा आई से. ओके, वन लैम्डा इज इन स्केलर एंड इसका जो डिटर्मिनेंट है ना, इसको इक्वेट कर देना जीरो से, इसको इक्वेट कर देना जीरो से. नाउ वंस यू सॉल्व दिस पर्टिकुलर इक्वेशन यू विल गेट अ पॉलीनोमियल वैल्यू इन फॉर्म ऑफ लैम्डा. You will get a polynomial equation in form of lambda. Okay, and this particular polynomial equation is actually known as the characteristic polynomial. Characteristic polynomial. This particular equation is actually known as the characteristic polynomial. Okay, now these values of lambda, from here if you find the roots of this particular polynomial you get values of lambda. Now these particular values of lambda are actually known as eigenvalues. Now we won't dive into details of what is eigenvalues and why do we need to calculate eigenvalues, but still we will actually talk about Cayley-Hamilton theorem. Now from here, what Cayley-Hamilton theorem says that this particular characteristic polynomial is also satisfied by the square matrix A. So if in terms of lambda we actually replace lambda with the square matrix that is A, then we get the characteristic equation, and that is also actually the Cayley-Hamilton theorem. So this will be something a ki power n minus 1 and so on up to some constant times of I identity matrix, which is equal to null matrix. Okay, so this is actually known as the statement of Cayley-Hamilton theorem. So basically you have to actually solve this particular determinant value. From here you will get the values of the eigenvalues, and from the eigenvalue you actually have to form the characteristic polynomial to get to the characteristic equation of the matrix. Again, another way to represent Cayley-Hamilton theorem can be now any square matrix with a higher power can be actually expressed as some constant times of A plus some another constant times of identity matrix. Now this is another statement of Cayley-Hamilton theorem. Now with this statement, इस स्टेटमेंट का यूज करके ना वी कैन गेट बैक टू मेनी अनदर इंपॉर्टेंट रिजल्ट्स. मान लो अगर मैं बोलूँ कि एनी पर्टिकुलर स्क्वायर मैट्रिक्स एक्चुअली कैन बी रिप्रेजेंटेड एज दिस पर्टिकुलर रिलेशन, एक्चुअली वी ट्राई टू फाइंड दिस पर्टिकुलर रिलेशन विद द हेल्प ऑफ Cayley-Hamilton theorem. Now what we can say from here, if the matrix equation is satisfied, then this equation will also satisfy by its eigenvalues. And we know that अगर स्क्वायर मैट्रिक्स का eigenvalue है lambda, then a की पावर n, मतलब if you take the product of n times, then इसका जो eigenvalues होगा वो होगा lambda की पावर n. So from here we can also satisfy then get this equation lambda की पावर n is equal to c1 times of lambda plus c2. ना यहाँ से अगर मुझे equation मिल जाए, we can directly get to the solution of c1 and c2 from here. If there two equations are there and we can get to the equation constant of the two equations, then we can directly get to the result. So ये वाला जो help है ना, ये basically 2x2 मैट्रिक्स के लिए काफ़ी ज़्यादा हेल्पफुल होगा. 2x2 को सॉल्व करने के लिए काफ़ी ज़्यादा हेल्पफुल होगा. ओके, सो लेट मी टेक अ क्वेश्चन टू इलस्ट्रेट माई सेइंग. सो फॉर एग्जाम्पल इफ वी आर गिवन विद अ क्वेश्चन, द मैट्रिक्स दे रखा है विच इज गिवन एज 1 2 0, दिस इज 2 ओवर हियर एंड फ्रॉम हियर वी आर एक्चुअली हैव टू कैलकुलेट a की पावर 9. अब देखो बेटा, अगर a की पावर 9 कैलकुलेट करने जाओगे ना तो यू हैव टू टेक सम लाइक can you do it by directly multiplying the products? It will take some time and it is very tedious also. So क्या करें, we actually take the help of Cayley-Hamilton theorem from here. Now, by Cayley-Hamilton theorem, what I said by the second statement, that if any matrix to its higher power can be expressed as some constant times of that particular matrix plus another constant times of identity matrix. Okay. Now, what if we try and this particular equation will also satisfied by its characteristic equation, the eigenvalues. So we can write like this. Okay. So what I do, I firstly find the eigenvalues. Now I said the eigenvalues is actually calculated by this particular determinant value and equating to 0. We get a polynomial in form of lambda. From here we get the roots of the lambda which is equal to the eigenvalues. Okay. So let us solve the eigenvalues. क्या आएगा eigenvalues यहाँ पर solve करने से? अगर हम देखेंगे तो 1 minus lambda, 2, 0 and 2 minus lambda. Now if we take the determinant of this particular thing, what we will get? We will get 1 minus lambda into 2 minus lambda is equal to 0. Now this thing can be written as lambda is equal to 1 and lambda is equal to 2. So we get the roots or the eigenvalues as lambda 1 and 2. Now what we do, पहले तो lambda का value 1 लेंगे ना, अगर 1 लेंगे तो 1 is equal to c1 plus c2. We can write like this. And similarly, because n का value जो है ना, we have to calculate for n is equal to 9. Okay, and similarly if lambda is equal to 2, then 2 to the power 9, that is 512, we get c1 times of 2 plus c2. Now what we do, we subtract this particular two equations, we get c1 is equal to 511, and from here we also get c2 is equal to, if this is 511, so then the value of c2 will be basically minus of 510. You can check from here. So from this we can directly get to the result, that is a की पावर जो 9 का जो वैल्यू होगा ना, वो क्या होने वाला है, that is 511 times of a minus 510 times of identity matrix. So from here we can directly get to the result. Okay, so I hope this particular question will be very useful in solving higher order matrices. Okay. Now we can also solve this particular concept by taking out the diagonal concept of the matrix, which we will later learn in the chapter of linear algebra. Okay. Now let us move further and solve some question which is basically some JEE mains questions. Okay. Now this type of question actually asked in JEE mains. So whenever we actually try to solve this particular question, we don't actually have to calculate the actual value of A inverse and then relate it with this particular thing. We can directly get to the result by using Cayley-Hamilton theorem. So what I will, पहले मैं क्या करूँगा ना, Cayley-Hamilton theorem के लिए जो characteristic equation का value मैं निकालूंगा. तो यहाँ से क्या करूँगा, जो मैट्रिक्स है उसको माइनस करूँगा लैम्डा टाइम्स ऑफ आइडेंटिटी मैट्रिक्स एंड इसका डिटर्मिनेंट इक्वल टू 0 करूँगा. ठीक है ना, इसको 0 करने से वी विल गेट अ डिटर्मिनेंट वैल्यू. Now if we solve the particular determinant, then we get to that eigenvalues, and from the eigenvalues we will get the characteristic equation which is satisfying some polynomial in the form of matrix. So let us start and do that. And if we equate it to 0, what we actually get the result as, that is 1 minus lambda times of this will be 4 minus lambda into 1 minus lambda minus of minus 2, that is plus of 2, and we will equate it to 0 if we are expanding on the first row or the first column, whatever you think like. Okay, and then from here we will get this result as 1 minus lambda multiplied by this particular, if we solve this we will get 4 plus lambda square, and this will be minus lambda, and the minus 4 lambda, this is minus 5 lambda plus 2, which is equal to 0. Now from here what I will get, I will get lambda square minus 5 lambda plus 6 multiplied by lambda minus 1, which is equal to 0. Now from here if I try to solve and get the cubic equation or cubic polynomial, we will get lambda cube minus 5 lambda square plus 6 lambda minus lambda square minus this will plus times of 5 lambda and minus 6 is equal to 0. Now if I solve this and get the cubic equation, if you simplify, there is lambda cube minus 6 lambda square, okay, and this will be plus 11 lambda and minus 6 is equal to 0. Now this particular is a characteristic polynomial. Now each square matrix, this is a square matrix, satisfies this particular characteristic polynomial. So what we can write from here, we can actually write this. So we can write this particular thing as in form of a determinant of A in form of matrix. Okay, we can write this A cube minus 6 times of A square plus 11 times of A minus 6 of identity matrix is equal to null matrix. Now what if we try and multiply by A inverse, we will get the result as A square minus 6A plus 11 times of identity matrix is basically equal to 6 times of A inverse. That was what was actually asked in this particular thing. Now 6 times of A inverse is equal to A square minus 6A plus 11 times of identity matrix. Now from here if we compare the result which is given in the question, we will actually get C का value जो आएगा that is minus 6 and D का value जो आने वाला that is 11. So from here C plus D will basically equal to 5. This is the answer to this question. So कितना easily इस question को जल्दी से solve कर सकते हैं by the help of Cayley-Hamilton theorem. I hope this particular solution is clear. Now